Building a QuickBooks-style database for music using Microsoft Excel. This time looking at distance notation, traditionally known as intervals. So get ready and some coffee because we're going to excel at automating Excel. Here we are in Excel. If you don't have access to this workbook, that's okay because we basically built this from a blank worksheet but started in a prior presentation. So if you want to build this entire worksheet from a blank sheet, you could begin back there or just follow along, possibly building the part of the table that we're currently working on. If you do have access to this workbook, though, 4 tabs down below: example, accounting, practice, blank, example, in essence, the answer key, the accounting tab, the analogy that we might refer to, the practice tab, having pre-formatted cells. So you could practice the practice problem with less Excel formatting, but if you don't have any of that, that is okay. We will continue to work in the blank tab where we started with a blank worksheet, continuing in essence in the blank part of the worksheet. So in prior presentations, we've been using an analogy of an accounting system to think about how the information is organized within a DAW type of system for music. And we've thought about the notes being analogous to the accounts, the numbering of the notes being analogous to giving account numbers to the accounts. We've thought about our engine that allows us to look at the reports from different perspectives. So it's not really a filter, not really a sorting, but kind of a pivot of the reports. We've looked at the idea of our DAW, which has the x-axis as time and the y-axis as the notes. And then we thought about other ways that we can drill down on 1 unit of time, or inversely, if we're doing the data input with an instrument, we are using the instrument as our data input to put the information in. And that's where we've been recently, similar to if you're looking at a QuickBooks system, the idea of the forms. The forms, although they all create basically journal entries, they're all debits and credits. We have individual forms that are specifically designed for certain data input, making that data input easier. So for certain type of music, you might use a different instrument, a different interface, a different form, in essence, a guitar, a piano, and so on. Or you might just want to optimize the visualization of your DAW using what I would think of as like the most Platonic kind of field of music, which would be the 12 by 12 grid. And so that's what we've been mapping out here. I'm going to go back on over and say, let's unhide. I'm going to unhide some cells, right click and unhide. So we thought about mapping it out this way, just by having 1 octave this way, and then basically the other octaves on up and down. And then we thought about creating a grid, the Platonic grid, which now I can visualize a MIDI system that can simulate any instrument by mapping things onto this grid or lattice of 12 by 12 grids, mapping any instrument onto it, and then taking that to make it into whatever instrument, such as a guitar fretboard that now has the ability to pivot around the different ways to view our information. Now, we talked about last time the fact that I can do this now with points. So that's what most people think of when they're visualizing like a fretboard over here, whatever their instrument is. They usually want to see the notes, but if you have all the notes, it's too much. You just really want the notes that are in the collection, whatever the relative collection. This one is now mapped out to the key of G major, what I would call 11 o'clock. But it would be great then to have this grid map out as it's doing through all 12 collections of notes from 1 perspective. And then we saw that we can then see the points in 2 different ways thus far. These are both landmarks, what I would think of as like if you're on a planet, 7 continents, 5 oceans. The oceans are not going to be populated, only the continents populated. And if we did those with just note letter and note number, there we have our population in that format. That's great, but you also might want to look at it by basically the mode point. So I can take on the mode letter and the mode number. So now we have the other way of visualizing it, remembering that if you're looking at it by the notes, I would say that that's kind of like if you're in space and you had a star above each of the continents and oceans, 12 stars up above, you're naming them by the stars, even as the planet rotates underneath. Whereas if you're naming them by mode, then what you're doing is saying, I want to pick the relative degree of rotation and then name all the points by the location on the planet. North America, South America, Europe, and so on. So those are the differences. But you can also name it by distance. So that's the thing we're missing now. And if I name it by distance, I need another thing involved, meaning I might want to look at everything from the perspective of, like, if it was a planet, Europe, if I'm in Europe, what are all the distances to the other locations from Europe? Now, remember, it would be more similar to like all of the continents and oceans are on the equator and we just go around in a circle, right? So I want to know the distances, only going clockwise to start off with at least, to get to all the other locations from one point. So that would be great because then I can map out on my fretboard if I'm playing in whatever mode I'm playing in, whatever collection, and then the other dial, whatever mode, I can put distance by that point. So if I look at my example over here, we have our distance notation on this one. I'm using a distance notation that is relative to a modal point. So for example, in our analogy, if we have 7 continents and 5 oceans, it would be measuring from a particular continent, such as Europe, for example. But we could also imagine using scale degrees here, measuring everything from one point from a scale degree perspective. The problem with scale degrees is they kind of combine together the point and the distance, so they're a little less precise in that way, but we'll try to do both. Let's go back on over to the blank tab, and I've now X'd off the note letter and the mode number, just to get a quick idea of what we're talking about if we're thinking about distance. So I also want to change the collection of notes, so I'm going to hide everything to do that. I'm going to go from here all the way over to where our engine is, so that we can play with this a little bit in terms of the collection of notes. So we can go out to, let's go out to here, right click and hide. And let's just bring it back to 4 o'clock for now. So collection of notes around the key of C. So now the C is the Ionian. Now, if I'm going to be measuring from this point, remember, there's distance notation, like we're imagining the stars are above the planet. If we had a planet, we have 7 continents and 5 oceans, and they're all on the equator, let's imagine, and the planet is rotating clockwise, and there's a star that is fixed in the sky above each planet and ocean. Therefore, there's 12 stars. So we could measure things from space, from the stars in space would be like the strings on the fretboard, and say that we have 12 units. But we also know that the planet is rotating into 12 positions underneath the stars. So we can also measure things once we're on the planet, would be one way to think about it, which means that the 7 continents and 5 oceans are always the same when you're on the planet, even though the planet is rotating relative to the 12 stars above you, right? So that means that we have 2 kind of measurements that we can take, one from the perspective of space, let's say, one from the perspective of the planet. And that's where things get a little bit confusing with the traditional naming system, because they kind of combine those together with the concept of scales and scale degrees, which abandoned or kind of moved away from a traditional coordinate system to what we call an ordinal system. Which causes a lot of problems. To my mind, that was an error. That's an error that we've been dealing with. So, okay. So that means that, like, for example, if I'm measuring from an Ionian, I always have 7 continents and 5 oceans. So you would think that you would measure from the Ionian and say that now I'm going 1 continent up to the Dorian. The next continent up would be Phrygian. The next continent up would be Mixolydian. Now the continents are not evenly spaced from space, from the stars, because there's no ocean in my ocean continent analogy between nodal point 3, Phrygian, and nodal point 4, Lydian. That's okay. You could still measure the distance as though you're continent hopping, like island hopping, even though two islands are together. That would be fine. My suspicion is that caused them a problem in history, and they didn't want to use a measurement system because they thought it was uneven. It didn't easily go back to the half steps. Therefore, they implemented the ordinal system, which I think kind of was a mistake, because you can use measurement systems even though there's not an even amount of units between them if you're counting the continents, even though the oceans are not evenly spaced between them, or if you have two continents that are stuck together but they're two continents, right? You could still say I'm going continent to continent to continent. So that's where we end up with the scale degree kind of confusion in there. Okay, so that's what we're basically trying to do. Now, if I start at a different point like the Mixolydian, then I could measure continent to continent to continent. So you would think you would measure from Mixolydian. One continent up would be Aeolian, another continent up would be Locrian, another continent Ionian, and you would think that you would have a fixed numbering system for all of the continents as you go around them in a circle, as though they were just simply on the equator. But no, the ordinal system changes the numbering system. So now if you were starting on this one, continent number 5, Mixolydian continent, you would name it from a scale degree standpoint, number 1. Scale degree 1, even though it's Mixolydian continent, which would be 5 if you were from the perspective of the Ionian. So that whole renumbering and renaming is a result of the ordinal system, which again, I think is kind of like an error, right? I think it's an error. Okay. So now we have to think, so I'm going to try to say, what is our normal naming convention and what does it actually mean? Let's build a table out so that I can then create my fretboard so that I have the distance in the fretboard. So I'm going to select from here back to here. I'm going to right click. I'm going to unhide, and I'm going to go all the way back because I want to be over here next to where I was doing these data inputs in my worksheet. It's in column BB, and I'm going to put it here because I would like to make this data input also have a system of distance notation. So I'm going to put my cursor on BD, and let's go all the way over to let's give us to BU, right click and insert. And then I'm going to make those a little larger. And this is where we'll start working. Okay, so now let's think about distance as a general rule. If we're just taking a look at half steps, I'm like thinking from space, from the stars in space, then let's put it right here. I'll put the half. Let's put it down here. We got half steps. I'm going to put it a cell down because I'm going to have other stuff to the right of it. And let's say that we could be on the point that we're on, which would be point 0, right? And then if we go 1 up from there, it's going to be 0 plus 1 to 2. To 1. And then I'm going to go down. That would be 11 steps that we would have. Why? Because we're imagining we have from space 12 stars that are the notes that are in space that are hovering over 7 continents and 5 oceans on the planet. And then at any point, any reference point, whatever that reference point is, whatever note it is, A, B, C, D, whatever, A sharp, right, sharps or flats, I could start there, and that would be point 0, you would think, and then I would be going a distance from that point to another point. Now, just remember, from a measurement standpoint, the point you're standing on is not the point that you're measuring from. That's just a standard error in measurement that happens all over the place, right? We've got this off by 1 problem happens all over the place. The first point, the first landmark isn't the first step that you take. If the map says that you need to take 10 steps from the oak is the landmark, but it's not step 1, okay? So that becomes kind of an issue that comes up, okay? So that means that if there's 12 places, 12 notes, whatever note we stand on, if it goes around in a circle, then that means we can take 11 steps from there, and that brings me back home. You could see the situation like in a clock, obviously, where that's exactly what they did. They started at 1, and then it went up to 12, and then it went back to 1. You would think it would make kind of more sense to start at 0, and then it goes to 11, and then it goes back to 12, or instead of saying 12, it should be 12/0, maybe 0/12, right? Something. But that's the classic kind of problem. Okay. So then if we look at the intervals, let's think of our interval conventions. Usually, now I'm just going to list out the interval names here. The interval names historically became a mess. Why did they become a mess? Because this is my interpretation. I'm not like a historian on this, but I've looked at it for some time. The Pythagoras was looking at ratios, and he liked the perfect ratio, which to us is the perfect fifth, right? So that became really important. So when we ended up with 12 notes after having 7 notes, they wanted to make the perfect fifth special, therefore they called it perfect. So, and then we were always playing in the key of C, or the major scale, Ionian, from the perspective of the Ionian as the root, and therefore they wanted to compare everything else to the Ionian. Why was the Ionian special? I would think it's because it has that leading tone that goes home. That's the leading tone from a voice leading. So they wanted to compare all the other, if you start on any other point, to the major. Now that becomes kind of an issue because when you're measuring distance, you only need one ruler. Like you wouldn't really want to measure the distance. Like if you're from Europe, you don't want to measure the distance from like America to Canada or something by using Europe to America as your ruler. That seems kind of weird. So that becomes kind of an issue as well. So we have kind of historical baggage of one, Ionian or major scale was super important, so they made their distance notation based on it primarily, and 2, the perfect interval was super important, therefore they made another like notation for the perfect interval. So let me show you what I mean. So if we don't move anywhere, we call that a P. I'm going to call it a P1 because we didn't actually move any distance, or if you went a whole octave up, then that would be a perfect interval. Okay, but if I start on the first one, then we're going to call that usually a minor. I'm going to say Mi2. So for a minor 2, and maybe you put a lowercase. The reason I want an I in there is because when I do color coding, it's not going to be able to pick up just the M. Therefore, I want to have an MI so it'll pick up when I put colors into these. And then, so notice if I was going to look at the easiest notation for distance, it would be tonic, let's say, and then I'm just going to say it's either a short or a long distance. Now, so remember, there's 2 things that are happening here. There's a distance as though we're on the continent, and we're moving position to position on the planet, continent to continent. But there's oceans in between, and the oceans are spaced using the formula from the perspective of the Ionian, whole, half, whole, half. So what that means then is if I start on any continent and I move to any other continent, there's only 2 options depending on what continent I started from. Either that distance is going to be long or short if I take both continent and oceans together, right? So in other words, if I'm island hopping in Hawaii and I'm going from island to island and I'm saying I'm going to the 3rd island over, then the 3rd island might have 2 oceans in between it, or maybe it's got 1 ocean in between it because 2 islands are kind of stuck together or something like that, right? So that's going to be the same analogy here that we're kind of looking at. So the minor second would be 1 continent up, but from whatever continent we start off. We're going to say we're going one continent up in essence, but it's the shorter of the two distance. So I would call it a short distance, a short one distance. Okay, so this will hopefully make more sense as I go. So then if I go 2 steps up, that's going to be a major. So I'm going to put a capital M, A, and then second. Now notice that second is saying that it's the second scale degree. So this is where the ordinal system becomes kind of an issue. We don't really know where we're starting on because we're not naming the continent that we're on. But wherever we started on, it has a second scale degree. So if whatever we were on, we count it as 1, this would be the second of it. Now, if we were measuring from a distance perspective, it would be what I would call the first modal half step, meaning you only took 1 step, meaning all the scale degrees are basically off by 1. That would be like you're island hopping in Hawaii, and you're going to and you're going 3 islands over, but you're going to call it 4 because you count the island that you're on. You're going to the 4th island, right, from an ordinal system. Or are you going 3 islands away from the island that you're currently on? See, so if I'm doing distance, I would rather say I'm going these many islands away. So this will be a long then, what I would call a long first modal half step. And then 3 notes away traditionally would be called a minor third. So again, now we're going, if I count the continent that we're on, we're counting it plus 2 continents up. So I would rather call that let's do it this way. This should be the tonic is 0, let's say, and then this would be a short 1, and this would be a long 1. First modal half step, second scale degree. And then this one is going to be a minor third, which would be a short second, because again, all the scale degrees are off by 1. Or if we go 4 notes up, that's what we call a major third. So whatever continent we were on, we count the continent that we're on, ordinal system, and then we go up another 2 to get to a major third, which has 4 notes away because the ocean's in between them. So I would call that a long second modal half step, meaning if I was doing modal half steps, it'd be a long second. And then if I go 5 up, that's what we call a perfect fourth. Now, that becomes a problem because it's like, okay, well, why did we go to perfect all of a sudden? Because we had kind of like this pattern where the majors ended up being long distances of the 2, long distance. The minor ends up being the shorter of the distance, but now you have perfect. You would think it would be major, but because the 5th is the inverse of the 7th, which was the kind of original perfect interval, it should be perfect. They wanted to give it a special name. So you would think it would be major, but now they kind of upgraded it to perfect. And this also happens to be where it's backwards. This perfect distance isn't the long distance, as you would kind of expect. It's the short distance. So for this one, this was going to be a short third modal half step, right? Okay, and then the 6th. Now this one's a little weird because it's right in the middle. So that means that because you did a perfect up here, like the 6th, you would think would either be an augmented fourth, meaning if this was major, you would think that the next distance up would be the minor or the other one of the 2, but it's being pushed up instead of down. The minor would have to be up 1 instead of down. So that's why we have to call it an augmented. It would be an augmented 4. Now, it could also be a diminished 5th, but let me show you why real fast. Now we have the 7. The 7th distance away would be the 5th. And that's the one where, again, they deviated from the major minor. They elevated it from major to like a perfect 5th. Okay, so now we have a perfect 5th, which is 7 notes away. But what about the half distance, or what about the other distance? Well, it's the sixth. So the sixth is right in the middle of our distances, right? So you end up, it gets messed up right in the middle here because of the formula whole, whole, half, whole, 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 half. So this one could either be a augmented fourth or a diminished fifth. So I'd rather call it either a long third or a short fourth, right? Because so now because they compared stuff to the major scale, you end up with this idea that, well, the majors are usually long and the minors are short, except the perfects messed it up. And the perfect fourth is actually the short distance, which would be major, but they kind of pushed it to perfect. And the perfect fifth would be the major distance, which would be a normal long distance, but they made it perfect. And the fact that they made it perfect forced us to use other notation for distance, which is the augmented fourth and the diminished. So now instead of just having 2 units, long or short, of each of these distances, we have 5. We've got major, we've got minor, we've got perfect, which forced us to use augmented and diminished. So that's clearly a lot of baggage that we have here, right? So the perfect fifth, I would rather, it would be more logical just to say it's the long long fourth, and then we're going to say, because the scale degrees are off by 1, and then an 8 note away difference is going to be a minor 6. So now we're back to kind of like normal. A minor 6, it's off by 1, would be a short fifth modal half step if I just count continents. And then we have the 6 note away, the 9 note away is going to be a major sixth. And that would, I'd rather call that a long fifth, because again, if I count from the point we're on, all the scale degrees are off by 1. 10 notes away would be a minor 7. So that would be the last scale degree, because there's only 7 continents as we go around the circle. But if you're measuring from any particular point within the circle, it would be 6 away, right? So it would be a short 6 for 10 notes away. And then 11 notes away would be a major 7, and that would be a long 6. So you could see, if I compared the two systems, an ordinal system and the measurements from it versus just a normal measurement system, you could see the simplicity or the complication of the ordinal system, right? You end up with major, minor on the ordinal system. The majors are usually the longer of the 2 distances, because there's only 2 available distances from each point. And they deviate from that pattern with the perfects. And because they added the perfects, they also had to add the augmented and diminished. Whereas if you just said long short, you would end up with a pattern of long short all the way through. We still have this kind of issue on the 6th here, where it gets kind of messed up, right? Because you have the long third and the short fourth are kind of the same area, because that's the midpoint of this whole thing. But again, this notation, like you could see, the notation got a little bit messy, which is kind of a problem given the fact that it's a basic notation. It's also going to be a little bit difficult to measure like to the left, right? Because this notation is kind of thinking of going clockwise, not so much like counterclockwise. Okay, but that's what we have. Now, if I'm going to also add the 0 up front, so this is what I'm going to say is it's 0 note away, perfect, and then I'll say first. And then this is going to be a 1 note away, minor second. This is going to be a 2 note away, major second. This is going to be a 3 note away, minor third. This is going to be a 4 note away, major third. This is going to be a 5 note away, perfect fourth. This is going to be a 6 note away, either augmented fourth or diminished fifth. And then this is going to be an 8 note away, minor 6. This is going to be a 9 note away, major 6. This is going to be a 10 note away, minor 7, and an 11 note away, major 7. So by doing that, if I was to populate my fretboard with this terminology would give me everything, right? It's going to give me how many notes away it is, and it's going to give me the interval, major, second, and minor, and so on and so forth. So that's what I want. Now, I would also like to have what I would think of as a more modern distance notation, which is going to be based on nodal point distance. So notice that this distance notation is a generic distance notation, like this is. It's a generic, these are kind of generic distance notations because I don't know where I'm starting on, right? I don't know the point that I'm starting on when I apply these terms to it, because if I look at a collection of notes, I have 7 starting points. Like if you have 7 continents that are around the equator, and there's 5 oceans in between them, 5 oceans, 7 continents, and you're going around in a circle, I could start at any one of those 7 continents and then go clockwise around the circle. That's basically what's happening here. And these names would be applicable depending on where you start, basically, if you land on another continent from there and so on. That would be the general idea. However, I could be more specific than that if I name or number the 7 continents, like I give them a Nashville number 1 through 7, or I give them the mode numbers: Ionian, Dorian, Phrygian, Lydian, Mixolydian, Aeolian, Locrian, and then I know that they're all in order as I go around the circle. I could just tell you this is an Ionian first, right? If I say it's an Ionian first, then I know if it's going to be short or long, right? I'll know the distance notation because I'm measuring from, if I'm island hopping in my plane, I know the distance from each island to each island because I know the map. So if I say it's a Dorian third modal half step, I know the distance from that Dorian island if I go clockwise around the equator to the next island. So that would actually be a lot more specific of a notation if I think of it as basically a map. And then I'm instead of measuring from the stars in heaven, instead of measuring from I'm going to think about the degrees of rotation that we're on, and then how far we are from one continent to the other within that degree of rotation. So that's what we'll work on next time, and I'll also color code this. Now, ultimately, what I'd like to do is have this populate into these 12 by 12 grids. And if I can get this to populate into a relative 12 by 12 grid, you would think I can do a similar kind of thing here to toggle this thing on and off. I could just add another X and toggle on and off. However, to do that, I do need that added notation of perspective, like what's the modal center. So by doing this, if I look at my 2 dials, if we have a planet that is rotating and I'm trying to measure that planet, I need to see the degree of rotation. We saw that before. That gives us the points, which I can visualize from space as note points or from the planet as mode points, modes and ocean points, Nashville numbers. And then I have the center, the modal center. The modal center isn't as important if I'm just looking at the points. But if I want to measure from somewhere, I need to designate the modal center. So I need the modal center for this next piece so that I can then say, what's the distance from that modal center? Remembering also, though, that I'm basically starting off at least to measure everything clockwise. So everything's going around in a circle. I can measure it clockwise. I'm not taking into account octaves, and I'm not going counterclockwise. In theory, we could go counterclockwise, right? And you could go up an octave and so on and so forth. But for right now, we'll keep it, the standard notation is going clockwise. So, and so that's what we're going to try to populate.